Today we're going to be working on the acceleration lab. This is the lab that looks like this. And what you're going to notice is on the picture, we have these books which are here, a ramp, a motion sensor, and a cart which goes down. Or in other words, we have a ramp, books, a motion sensor, and a cart which is going to be going down. Now notice this is at a slant. And so because it's at a slant, we're going to have an acceleration to it. And remember, an acceleration is a change in velocity over time. So we're not expecting the velocity to stay constant. We're expecting it to go increase over time and at a regular rate. So that's why on the second page of your lab, you have the data table which is associated with it. And so you have the different times and the velocities. Like with most labs, what you want to do is you don't want to just take one run as being your standard. You want to go and take multiple runs and then take an average. That's why we have 3 runs and then the average afterwards. Now we have 2 setups which are going on, and so you've got to check to make sure that your data is for your class, because it's possible that another class could be using another set of data, so they can, so not everybody's doing the same analysis. In addition, if we think about it, why do we have these books here? We have these books here to have a height. That gives us a slant. That gives us an acceleration. And so therefore, knowing the height of this is going to be very important. In addition, we want to go a particular length. And so it's going to be 1 meter length. That's what we're talking about with this particular ramp. Another couple of things to mention is that we have a program which is here on Pasco. This particular program, as you're going to see, it has time along here, velocity along here, and then a graph of velocity time. Now, that is what we're going to generate. We're going to generate this particular graph. Now, interesting thing to note, if it's a velocity time graph, think about what the slope of this particular thing is going to be. I'll let you guys think about that. Slope, remember that's rise over run, the y over the x. So what is velocity change over time? All right, so what we're going to do is we're going to go, and I'm going to go and hit the record button. And then what's going to happen is it's going to go down and it's going to record the velocities at different points. So I'm going to put the card here, and what you're going to notice is if I try starting this just by itself, you hear a little and then it stops. Well, that's because this is a motion sensor. It sends a signal out, bounces, comes back up, and it measures the velocity. Now, with that, it needs something to bounce off of. This is the thing it needs to bounce off of. But we also have to go and tell it when. So it's going to start at 20, and then it's going to go and end at 80. And so that is the area that it is going to be measuring for. So we're going to take a run. So I put this guy here, start at rest, hit this. You'll hear a little tick, 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 tick as it starts, and now I run it. Now, if we take a look at the graph which was generated off of it, that's pretty darn good. That's a relatively straight graph which is there. So what you're going to do is that you're going to go and input the velocities and times 3 times for the 3 runs which you have. Then you're going to take the average. Then you're going to put that on data analysis, which once again will enable you to get the slope of the curve, which is going to be the acceleration down the ramp. So get your data, get going.